Good morning, good afternoon, or good evening, everyone, depending on where you are now. And very welcome to our Smart Building and Digital Engineering MSc program Open Day. And regarding today's test lecture, basically, we have four elements to cover. The first thing is very brief introduction about our university and school. The second one is the SBDE MSc program, the overview of the whole program. The third one, I will give you a test lecture on one core module called Machine Learning in Smart Buildings. And last part, so basically, is the QA session. And if you have any questions, please feel free to post your question in the chat after the lecture. So basically, we'll work through all the questions and try to answer one by one. A very brief introduction about our university and school. Now we are the second in the UK for research power. In total, we have 11 academic faculties. For the SBDE MSc program, so in general, for this 1 year study, so basically you will have four targets to achieve. And you will learn the first thing is the scientific principles about buildings and their systems, how they are designed and how they are operated. The second one is about the data. You will learn how the data collected, processed, and interpreted, including some skills, knowledge about data analytics and application of machine learning in buildings. And also, this is the one thing we will cover later in our test lecture. The third one is after this 1 year study, you will learn how to take an integrated perspective of a building, its systems, and user for effective operation. The last one is you will establish solid understanding on the factors affecting integrated building design in relation to sustainable operation. If you are inquisitive with a strong desire in innovative modeling techniques, have a robust quantitative background with a degree in a degree with background of engineering, science, or related technical discipline, are digitally focused and keen interest in digital technologies, and you want to use your model, you want to learn how to use the data, and also you are very passionate about creating a sustainable future for the built environment. So then this MSc in Smart Building and Digital Engineering is a good choice for you. After this 1 year study, after you graduate, you will be well equipped with knowledge, skills to be an ideal candidate for specialist roles in digitally focused companies, provide engineering, design, planning, and consulting services. In addition, if you want to further pursue your academic career, you will be well prepared to further your studies as a PhD student. How this SBDE MSc program designed? In total, you need to take 8 modules for these programs. In term 1, 4 core mandatory modules, and in term 2, so basically 2 mandatory core modules plus 2 optional modules. For these 2 optional modules, so basically you can select the modules beyond this SBDE program based on your own interest. So basically, we have a broader selections available there for your choice to extend your view to satisfy the need of your own interest. And the test lecture on machine learning in smart buildings. So this core mandatory module will happen in term 2. Afterwards, in term 3, you will have your dedicated time for your MSc dissertation. A supervisor, academic supervisor, so will work with you to work on your dissertation. So basically, it's a good opportunity for you to explore your own interest and strengthen your skills and knowledge on the areas that you are very interested. So by now, it's about the introduction of our university, our school, and this ICPDE program. So the next is the test lecture on machine learning and smart buildings. And I will base on some questions on machine learning in smart buildings to introduce how this module is designed and why we need to grasp the skills and the knowledge of machine learning and how can we apply machine learning technologies to benefit, even say, revolutionize the domain of smart buildings. For this module, so basically four objectives to achieve after the study of this module. So the first one is after this module, you can develop your own machine learning model and apply the model to solve the problems in smart building and support the improvement of building design or operation. So not only about develop your own model, but also you can identify most suitable method algorithms to very specifically focus on your own task and work. The third one is not only about implementation, through this implementation process, and you can also be aware of the limitation of your data-driven or machine learning models. So the last thing is through the process and through your learning journey for this module, you will establish your own hands-on experience. After that, you can do some coding work, basically to implement your own machine learning model using Python. So basically, this is the general objectives you can achieve after the learning of this module. Now, the first question is, what is machine learning? Nowadays, there are lots of buzzwords and people are talking about machine learning all the time. For example, deep learning, machine learning, artificial intelligence, lots of different buzzwords you may be hearing of them day by day. And what's the difference? So if you see the left-hand side of this slide, these three bubbles basically can give you a very straightforward sense the relationship between these three buzzwords. And for this module, so basically I will provide very detailed definition, explanation about the techniques available in machine learning. Now, back to what is machine learning. For artificial intelligence, the ultimate goal basically is to mimic how human brain works. Now, let me see the first two pictures, these two animals. I think one these pictures come in front of you. I think it's very easy for you to say, okay, the first picture is a cat, the second one is a dog. But the problem is that if I ask you, how you make the decisions. So why you can say the first one is a cat, and I ask you to describe the criteria or the rules you make these decisions. I think it's not that easy. Even say it could be very difficult. You cannot explicitly describe how you make the decisions to say the first one is a cat, the second one is the dog. The second example, if you see the red corner figure is swimming, and how human beings learn to swim. Even though you have excellent people to teach you, you still cannot learn how to swim without any practicing, right? And even say an excellent coach cannot explicitly describe the way how you swim. If you only based on listening the rules, so you cannot learn to swim. You need to base on your own practice to make your body to realize how to swim, how to make actions in the water. So what is machine learning? So based on the two examples, in reality, we have a lot of examples, a lot of cases. We cannot explicitly describe the rule, describe the criteria, how we make decisions. This is for our human beings. So basically, this is the process how human beings learn new things through practice, through the interaction with this new stuff. So the analogy for machine learning basically is enable machine to learn by itself without being explicitly programmed. If we compare with the expert system, so everything in expert system has been well programmed, but this is not the case all the time. And machine learning basically can provide new technology, even advanced technologies to solve complex problems that this traditional expert system cannot solve well. To give you an overview understanding on machine learning domain, so how this module are to be designed, we will based on the categorization of machine learning, supervised learning, unsupervised learning, and reinforcement learning. So this one or this type of categorization nowadays is the mainstream regarding the categorization of machine learning. On top of these three subcategories, we also introduce machine learning fundamentals. So basically how the model works and how can we train a model and test a model. In addition to these four parts, we also have practical applications. We will deliver some real cases, tutorials. So on one side, basically give you a sense how to apply machine learning to solve real world problems. And meanwhile, you can develop your own hands-on experience to implement machine learning algorithms through Python. The last one is guest lecture. So guest lecture is an opportunity basically let you to touch on the cutting edge research. More details about this module. So basically 10 weeks, 3 hours per week. In addition, we have actual reading materials to satisfy your further interest on this area. Now we discuss the first question, what is machine learning? The second one is why machine learning in smart buildings. So if we want to know the answer why machine learning should be in smart buildings or the combination between these two disciplines, first thing or the most important thing for us is to know what's the current concern of buildings and what's the demand from buildings. Now you can see these two figures about the energy consumption and the carbon emission from buildings. So in general, from the figures, you can get a conclusion. Basically, building is one of the largest energy user and carbon emitter around the world. In addition, how about the modern building? How about the modern building system? Modern building has become more and more complicated. On one side, so we have increasing demand on thermal comfort, indoor environment. On the other side, we have more complicated energy systems. For example, we have PV, we have battery, we have electrical vehicles. We expect building to be able to coordinate with other elements of this emerging energy system to provide a better operation for the whole energy system. So these actual elements introduced into this energy system, so basically complex the building energy systems, and which means basically we need more advanced technologies to deal with these more or increasingly complex building energy systems. In addition to the complexity of building buildings, and around the world now we have very intensive goals regarding carbon neutrality. For example, in the UK, we want to be carbon neutral by 2050. So that means we need to realize the low carbon transformation of energy systems. That means we need to introduce more and more renewable energy resources. For example, wind power, solar power, the main characteristics of this type of renewables are very intermittent. So this will cause the consequence for the power grid operation. So if you see the right-hand side of this figure, so this is a very famous phenomenon happening in California called dark curve. So if you see in the middle of the day, because of the solar generation, we can see the electricity demand from buildings even to be negative. So this kind of renewable energy resources will be challenging for the health operation of power grids. I think all of you here are very familiar with the energy efficiency. So basically, we want to use less energy to provide the same service. And if we consider this emerging demand of different elements, renewables, and from the power grid or the whole energy system perspective, we also want the building to be grid interactive. The reason is that we want a building because the fact is building is one of the largest end consumer in the whole energy system. So we want a building to provide some help for the absorption of renewables and benefit the operation of power grid. On the other side, from building itself, because of this low carbon transformation, we want to electrify the heating system. And meanwhile, we also want to electrify the transportation system. So you can see nowadays more and more electrical vehicles are running on the road. So this will boost the demand of electrical demand, further worsen the problem of power grid operation. So in such a case, we want our building to be grid interactive as another layer of concern for current buildings. There are a lot of benefits for grid interactive buildings. This is definitely win-win solution for both power grid side and building side. So if you see the right-hand side, these are typical four types of grid interactive buildings, basically to shape or reshape the low profile of buildings. Now we know the current concern of buildings being energy efficient and grid interactive. So the problem become more challenging, more complicated. We need more advanced technologies to tackle these challenges and problems. So this is the reason why we want to introduce machine learning into our building areas. So the next question is, we know the reason, and the next thing is, how can we use machine learning to deal with the problems in smart buildings? I use two examples here, basically to introduce how can we use machine learning to tackle the challenges happen in smart buildings. One example is how to establish the understanding of our building energy use in the future. So the second one is how to leverage the power of machine learning to help humans or help building operators to make proper, even smart decisions in buildings. So let me see the first example about establish the understanding of energy use in the future in our buildings. Because we are talking a lot on electrical load of buildings, even in the future. So we want this electrification to be happen because of the carbon neutrality goals around the world. If you see the left-hand side, there are a lot of reasons for us to accurately predict the low profile in buildings, either from energy efficiency or grid stability, cost saving. Plenty of reasons motivate us to provide accurate prediction for our building electrical load in the future. So what's the current situation on this regard? So in general, I say basic forecasting can be effectively performed using traditional statistical model, even machine learning approaches. So basic means we still have some challenges very hard to be properly addressed. I give two examples here. One is the peak demand. The second one is the sudden change happen in your buildings. So I will introduce one by one. The first one is about the prediction of peak demand in your buildings. So if you see the left-hand side of this figure, so this is a monthly electricity use of a campus building. And in this campus building, the electricity bill includes two parts. One is energy charge. The second one is a demand charge. So second, energy charge is very straightforward. So basically it depends on how much energy you consume within this month. Peak demand charge, so that means within this month, the demand charge will based on the maximum electricity usage to charge amount of money for your electricity bill. From the power grid perspective, so this peak demand is also one of the main concerns for the power grid. So basically, the power grid capacity need to able accommodate the peak demand from the buildings. If we rank the electricity usage in this month from the largest to the smallest, if you see the right-hand side figure, if we do the limiting on peak demand for 36 hours, the time is only 5% for this month, we can receive around 25% of peak demand reduction. Only from the number perspective. So basically, this is like 5 times reward. We put effort in 5% of time, we can receive 25 load reduction within this month. The problem is that if you look back of the left-hand side figure, so you can see these peaks happen in this month are very stochastic. So in general, the problem for peak demand is they are very important either from the building perspective, from the power grid perspective. They are very important, but the problem is that they are very stochastic, very difficult to predict accurately. So because of this challenge, it's very difficult to tackle. Machine learning techniques can step in to provide the power, to provide the strength to deal with this challenge. Now, the general idea to solve this problem is that we do the decomposition of electricity use in buildings. We separate electricity usage into normal part and the peak demand part. As I mentioned, the current literature, this normal part, that is the basic load prediction in buildings. Machine learning model basically is very capable of dealing with this part of prediction. For the peak demand part, basically they are very stochastic. We follow the nature of this stochasticity to develop a probabilistic model to deal with this peak demand. And afterwards, we combine these two streams prediction together as our final result. And you can see the red corner, this figure, these green zones. So basically, this is our final result. Basically, it's not a specific load profile. It's like a green zone. In this case, it's a range. It's a range. So basically, to cover all the possibilities for your future regarding energy use. Basically, you can base on the result to provide or to make well-informed decisions considering the risk. The second one is the sudden change in building conditions. So when we train a machine learning model, basically we base on the past to predict the future. There's an assumption behind. We assume the past and the future should follow the same pattern, even say the similar pattern. And this is not the case all the time. For example, if your building experiences retrofit, before retrofit and after retrofit, the situation is totally different. Even another example is the COVID time. So if you train a machine learning model before retrofit, and when retrofit happens, so this model will not be providing very decent result. Now the problem is that, or the challenge is that, how can we make our model adaptive to the new situation? In 2017, Google developed very famous breaking through a model called transformer. They developed this attention mechanism. So this paper is very famous in machine learning, even artificial intelligence area. Attention is all you need. So we can say this transformer or this paper basically laid the foundation of current large language model. Transformer is very capable of dealing with this time series or long sequential data information. And back to our load prediction in buildings is a very typical time series problem. So why not use transformer to deal with this adaptive forecasting in our buildings? So in this case, we apply transformer into our building load prediction to make our building adaptive to the new environment. And that means when unexpected event happens, there's no need for us to retrain a machine learning model in this case. The problem is that for our building domain, we have some specialties to deal with. So we borrow the technology of transformer, but we customize transformer into our specific domain to make the performance much better. We use real data to validate our new model based on transformer. So if you see the red corner, this profile, the orange profile, this red box is the COVID time. So lockdown happened in this red box, and before, so you can see before. This profile is the arrow of your machine learning model regarding the prediction of electricity use. So before you can see the performance is very good, but when lockdown happened, this kind of unexpected event happened. So you can see the profile is going up very quickly. The model cannot predict the current situation very well, but afterwards, very immediately, you can see the profile come back to very low value regarding the error. Only 2-3 days, the model can be adaptive to the new environment. And also, this is what we want, right? We want our model is capable of adapting to the new environment rather than retraining the model from scratch. The second example is how use machine learning to help us to make correct, even smart decisions. As I mentioned, the categorization of machine learning, reinforcement learning is one subcategory of machine learning. And reinforcement learning is very powerful technology in machine learning to help us make decisions. There are a lot of successful applications. For example, OpenAI, ChatGPT, O1 version. So basically, they apply reinforcement learning to improve the performance of the language model. And AlphaGo is another successful application, basically using reinforcement learning to play with the game. If you see the right-hand side, how reinforcement learning works, it's very similar as what we learn new things. So for example, when you're a baby, we use the picture of cat as example again. So when this picture of cat come in front of you, so when you're a baby, you don't know this picture is a cat. So you just give an answer. Most likely it's not correct answer, but your mom will give you the right answer. Will let you know, okay, this is a cat. And then through this interaction process, basically you will establish your own knowledge and your experience will be accumulated. So after a couple of years, as what we did today, when a picture of a cat come in front of you, I think it's very easy for you to identify this picture is a cat. So this is how reinforcement learning works. Basically, it's from this interaction with the environment to accumulate its own knowledge until it can perform as human being, even better than human beings. Now, how to use this reinforcement learning in our buildings? I use an example of building operation in this case to make the problems more complexity to showcase the power of reinforcement learning. We increase the single building to 4 buildings. So if you see the left-hand side, we increase the building of 4 to deal with the operation in this case. These 4 buildings are office building. So if you see the right-hand side, this red circle, this purple line is the aggregated load profile of these 4 buildings. If we want to do this peak demand limiting, as I mentioned, peak demand is very important. It's a big concern for both building side as well as the power grid side. So we want to reduce the aggregated load below this red line. So how can we achieve it? And meanwhile, with the minimum sacrificing of the thermal of the indoor environment. The way we reduce the electricity usage is through the reset the indoor air temperature set point. The left-hand side, this figure is show basically is the schematic of reinforcement learning. So here we apply reinforcement learning to make decisions, basically how to reduce the aggregated electric load below the threshold. So we can see the result directly. If you see this red oval here, this above profile is the baseline, is the profile in the previous slide. The lower one is the profile after we take some smart actions, basically to reduce the peak demand. And how we achieve it. So you can see this dash vertical line, the yellow one, the blue one. So this is the office hour. After that is the office hour. Before that is non-office hour. So you can see how reinforcement learning, how smart it is. It pre-cool the building before office hour. So you can see there's a very lower indoor air temperature profile here. It pre-cool the indoor environment before the office hour to provide a cooler environment. And the temperature slightly increase a long time. So this is a way basically to protect the cooling resource stored in your building in this green zone. So green zone when the violation of threshold happen. So you can see the indoor air temperature here are touching the upper limit. So in this way, basically the cooling resource stored in the building can release as much as possible. So if we only base on human beings or professionals, so most likely we cannot realize such an accurate, smart decision making to reset our temperature, to pre-cool the building, to release the cooling resource, and meanwhile to reduce the peak for our buildings. So we can see the strength of reinforcement learning, even say outperform human beings. So now is the end of this test lecture, and thanks for your listening. If you have any questions, so feel free to put your question in the chat, and I will try to answer your question one by one.